Hello, this is section 5.3, and this will be a lesson on some trig graphs. Between 5.3 and 5.4, we will cover all 6 of the trig graphs. Today, 5.3 is just sine, cosine, and tangent. Actually, no, it's just sine and cosine. So we're going to get just specific with those two trig graphs. In case you read the joke of the day here, why is a circle so smart? Because it has 360 degrees. All right, now we're ready. Here we go. So we're going to start out with just talking about a basic cosine graph. So y equals cosine x. And I want you to briefly think about your unit circle and what are all the cosine values going around to that, because when you graph a cosine function, that's what it's going to stem from. So I picked out some easy ones. Like, for example, I know what the cosine of 0 degrees is. And remember, cosine is always your x-coordinate. And so the cosine of 0 is 1. And I know the cosine of 45 is the square root of 2 over 2. But as a decimal approximation, I don't really want to think about that. So I'm going to, again, just pick out the easy ones. So cosine of pi over 2, x-coordinate is 0. Cosine of pi, x-coordinate at pi is negative 1. Etc. Cosine of 3/2 pi is 0. Cosine of 2 pi is 1. And you can kind of see a pattern maybe developing already. 1, 0, negative 1, 0. 1, 0, negative 1, 0, etc. So knowing that, if I kind of, now you're going to be graphing these on some trig paper. And so if you have, or actually there's trig paper on Schoology if you want to practice on paper. Otherwise you can certainly, label your paper in radians as well. So notice this, the x-axis down here is scaled by fourth of a pi, half a pi, etc., etc. So I just plotted like 0, 1. I plotted pi over 2 and 0. I plotted pi and then negative 1. And then the remaining 5 key points. So you can maybe see a pattern. And now knowing that beyond 2 pi, it's just going to start repeating 0, negative 1, 0 again. So it's going to come back down when it hits 3 pi and be at 0, and then etc. So it's going to kind of keep repeating this pattern right here. So if you connect those dots and keep going, this is what a cosine graph looks like without any shifts or reflections. So again, you can see this is 0, 1. This is pi and negative 1, and it goes on forever. Okay, so keeping that in mind, just again, where it's kind of stems from. Now, if we look at a sine graph, it's the same exact idea. Of course, sine is your y-coordinate. So if you think about easy y-coordinates going around the circle, sine of 0 is 0, sine of pi over 2 is 1, sine of pi is 0, sine of 3 pi over 2 is negative 1, and again, you could keep going. So same idea as cosine. If I plot those points, 0, 0, pi over 2, 1, pi 1, or pi 0, excuse me, etc., you, again, knowing that it's just going to continue and repeat that pattern, you can probably see the sine wave, and then it's just going to start repeating, and it will look something like this. So this is just the first wave, and I did one going the opposite direction as well. Okay, so that's, again, where the sine wave stems from, and we're obviously going to build on this. So key things that you'll want to pick out here, and I'm going to talk about the red and green terminology momentarily, but a cosine wave, just one cycle, so before it repeats, looks like this. And so some people kind of say, oh, it looks like somewhat like a parabolic shape. Obviously it's not, but you can keep that in mind with the cosine. The sine wave starts right on the 0, and then it goes up, down, and back to 0. Knowing the shape of these graphs, I think, will really help you, especially when we get to secant and cosecant and more challenging graphs. Okay, along with this, we're going to talk about terminology, but probably the two most important pieces to any trig graph is the amplitude and the period. So the amplitude is just the height from any min or max to the midline. So this amplitude is a length of 1. I could also go over to 2 pi and calculate this amplitude, still a length of 1. still a length of 1. So amplitude is a distance, a length, so it's always positive. Same with the sine graph. You can see the amplitude to the midline to the maximum, midline to the minimum, it's 1. Okay, the period length is the length of one cycle before it starts to repeat. So if it's the cosine wave starts at the max, goes down to the min, and ends again at the maximum, that length, in this case, that length is 2 pi, right, from 0 to 2 pi. That's the period. Same with the sine wave, starting at the midline, hitting the max, hitting the min, and then get back to the midline. That distance is 2 pi as well, which is called the period. Okay, I'm going to recap those words here. So these are on the note sheet that's on Schoology if you had printed this ahead of time. Otherwise, it's there for you if you did not, or you can write these out. Okay, so the functions, the cosine and sine functions, are periodic because the graph has a pattern that repeats indefinitely. So just to kind of show you that again, this is one cycle, but it goes on forever and ever and ever. Okay, so that's called periodic. The shortest repeating portion is called the cycle. Okay, so these are both one cycle cosine, one cycle of sine, and that's called the cycle. The horizontal length is called the period. Okay, so there's that important piece. I talked about that. And each graph has a period of 2 pi. Now that's going to start changing as we change different pieces on the graph. So we'll come back to that. But a basic cosine or sine graph has a period of 2 pi. The domain and the range, the domain is infinite. And you know that because the sine and cosine waves go on forever. And the range cycles between -1 and +1. And again, I can go back and show that to you. You can see it bounces between -1, +1. So that's just, again, some important information about your cosine and sine graphs. Now we're going to make it more challenging. Okay, so here are your cosine and sine graphs with every possible shift and or reflection that could take place. In blue, I have the ideal equation. In red is how you might sometimes see it. So please note the only difference between the blue and the red is the k is factored out here versus distributed in here. So if I distribute the k through kx minus kb, it's exact same equation. Okay, again, I can't stress enough, I think the blue is your ideal equation. If you can write it that way, it's easier to write, it's easier to read and translate, although both are correct. Okay, so this is sine, this is cosine, they're the same pieces, that is. Okay, this is just the variables that your textbook use. It does not matter if you use C, B, K, A. I mean, use whatever you want, but you got to know what they do. Okay, so amplitude is your A. And that's the height. We talked about that from your baseline, your midline, to either a max or a min. So this A, the number in front of your cosine or sine, that's probably the correlation you want to make. That's going to tell you how high and how low your max and mins go. Okay, if it's negative, it doesn't mean your amplitude is negative because it can't be. It just means now that's going to be a reflection. So if this, instead of plus A, would be like minus A, then you know that your sine and cosine wave, your max and mins flip-flop, and we'll look at one. Okay, frequency is how many times a cycle occurs between 0 and 2 pi, so in a length of 2 pi, and that's going to be k. So k, whether it's factored out, factored in, doesn't matter. That tells you how many cycles you'll see in the distance of 2 pi. So obviously the bigger k gets, the more shrinked your cycles will be. And the smaller k gets, I'm going to have less of a cycle between 0 and 2 pi. It's going to stretch out, and you will also see that. Okay, the period, I would definitely write this down, box this in. You're going to need to find period for all sorts of graphs. So how long does it take to complete 2 cycles? Well, if frequency is how often a cycle occurs in 2 pi units, then your period is going to be 2 pi divided by that. So 2 pi divided by your frequency is going to tell you your period length. So one cycle occurs within your period. And then lastly, 2 things you're probably very familiar with is your horizontal and vertical shifts. And so again, I highly recommend going with the blue. So if you factor the K out first, and this is just a recommendation, you don't have to do this, but if you factor out K first, then your B is going to be your horizontal shift. By the way, your horizontal shift is often called your phase shift as well. Same thing. Opposite sign, right? If it says left B or if it says minus B, you're going to go to the right B. Okay, and then your vertical shift is just C, and that's very straightforward. Whatever you're adding or subtracting, that can come before or it can come after your cosine and sine functions. Okay, so let's put this all together. I know this is a lot of information. So here is your first example, and I have a lot of stuff going on here. But this is the graph, the sine wave that we're going to graph. Okay, so taking a look at that, it's obviously lots of translations and reflections and all sorts of stuff. So off to the side, I'm going to just kind of go through these steps here. And again, it's a suggestion if it helps you graph these. Okay, so the first thing I would do, well, actually, the first thing I would do is identify all these important pieces. So you will be asked to state the amplitudes. Remember, amplitude is the height from the midline, and that's always the number in front of your cosine or sine equation. So 3 is going to be my amplitude. Okay, frequency is K, and that's always the number in front of your X. Okay, amplitude in front of sine, frequency in front of X, so that's going to be 2. Before I go any further, I would also note in the parentheses, do you see how K is factored in? Ideally, I would factor that out. So I'm going to go over here to my red equation. I factored this 2 out. If you can see, it's the same equation, right? So my frequency is still 2. Okay, period is 2 pi divided by your frequency. 2 pi divided by 2 is going to be pi. Okay, so that's how you get your period length. So it's going to be shorter, more squished. Horizontal shift in the parentheses plus pi means I'm going to go to the left pi. And my vertical shift minus 1, that might come after, that might come before. Either way, I'm going down 1. Okay, so just to make sure you can see all those pieces. The other really important part that I would hate to see you miss is there's a negative in front of the sine, and that means it's going to be reflected. So instead of a sine wave doing this, my max and mins are going to flip-flop, right? Like that's going to become a minimum, and this minimum is going to become maximum, so I'll come back to that. We got to remember that though. So once you identify your key pieces, then go in this order. Okay, so first I would dash in the midline, which is always K, because your graph is completely symmetric around that, always. So my midline is down 1, so I'm going to go and take this and make it my midline. Okay, so here I am at -1. Okay, second, I would dash in your amplitude from your midline because you know your max and mins are going to go a distance of 3, but specifically from my midline. So from my midline, if I went 1, 2, 3 above, and from my midline, if I go 1, 2, 3 below, this kind of boxes in my sine wave. Can't go above it or below those blue dashed lines. Third step, plot a point to have my horizontal and vertical shift. So I'm going to take these red points right here. Obviously, they're going to move, so I'm just going to kind of shove them up and away. But keeping in mind that a sine wave normally starts at 0, 0, but my horizontal and vertical shift say now you have to go to the left pi and down 1, and that is where my shifted translated sine wave is going to start, like for one cycle. Okay, fourth step then, now that I have my starting point here in red, is I can dash my period from that shift. So if my first cycle starts here, going through the red line, then my period length is only pi. So if I'm starting at -pi, my cycle is going to end at 0 because that's a distance, a period length of pi. So right in this region right here is going to be 1 cycle. Okay, so I know sine starts on the midline and it ends on the midline after 1 cycle. There's my period length, kind of halfway in between it, it's going to come back to the midline. Okay, now here's where you have to be careful and remember it's reflected, right? So from here, if I start here, rather than going up and coming back down, it's going to go down. So you can see halfway in between these 2 points, it's going to go down an amplitude length of 3. And then halfway in between the last 2 points of the cycle, it's going to go up an amplitude of 3. And so here is my reflected sine wave that is shifted and shortened, right? My period length is pi. So if I grab a marker here so I can actually draw the cycle so it's not just random points, if I connect these points here, I don't recommend just doing one cycle, but I just want you to be able to really hone in on that and understand where it's coming from. Okay, so this, now if I continued, it would keep going and keep going. It's cyclical, right? It doesn't stop. And of course it goes this direction to the left as well. But that's one cycle, and I'm hoping that that helps you identify how to get the full graph based on that first critical cycle. All right, let's try a cosine graph. So actually, maybe pause and see if you can pick out, first of all this key information and start sketching the cosine graph. Okay, first thing I did was factor out the 4, just to factor out the k, the frequency. Again, optional step, but I prefer to do that so I can see that horizontal shift easier. So 2, number in front of the cosine, is my amplitude. Frequency, number in front of x, is my k. Period is 2 pi divided by frequency, so 2 pi divided by 4 is 1/2 pi. Horizontal shift to the right, pi over 4, and the vertical shift is up 2. Hopefully you can find those pieces okay. So now my vertical shift is up 2, so I'm going to take my midline and I'm going to dash that in at 2. Right? Y equals 2. That's where my cosine wave is going to revolve around. These red points, by the way, is the original just cosine graph without any shifts. Okay, so I'm going to just kind of bop these out and get them out of the way so that's not confusing, but just a reminder of what it looked like. So I dash in my midline. My amplitude is 2. So from my midline, I know that I'm going to go up 2. And from my midline, I know it's going to go down 2. So kind of boxing in my midline. And then my shift is, my starting point for cosine wave is to the start. Normally it starts here. And I'm going to go, let's see here, to the right. Sorry, it starts at 0, 0. Go to the right pi over 4 and then up 2. Now that would be where our sine starts. Sine always starts in the midline. Cosine starts at the amplitude. Remember, it starts at the maximum. So it's going to go up to the amplitude. Okay, and then I'm going to dash in my period length. So my cosine wave is going to start there, and my period is only pi over 2, so it's really tiny, right? So if this is pi over 4, then when I get to 3 pi over 4, that's a distance of pi over 2. So my period, so my cosine wave is just going to squish in right here. Okay, so cosine starts there, and it's going to end at the max. Halfway in between this cycle, it's going to hit the minimum, which is right here. And then halfway in between the max and mins, it hits the midline. So as best as I can, that would be here and here. So again, very squished in there, but this would be one cosine wave, if I can kind of sketch that with my pen. And again, it doesn't stop there, right? It's cyclical, so it's going to keep going and keep going in both directions, but that would be one cycle. All right, so there we did a sine wave and a cosine wave, kind of covered everything that you might run into. Okay, the third problem is something on your calculator. If you are asked to find all of the solutions on an interval between 0 and 2 pi using your graphing calculator, okay, so I want to know where the sine wave, sine of x, equals negative 0.6. So if I, please note, first of all, on your calculator, okay, we only care from 0 to 2 pi. So right now, this graph that I have, I don't care about this whole area over here. I only care from 0 to 2 pi, so I'm looking in this region here. We're going to graph the sine wave. And you know the sine wave starts at 0, and then it goes up to 1, down to 0 again at pi, down to negative 1, and then back up to 2 pi. Okay, now you can pick up your calculator. So here's the deal. I'm guessing you haven't done a whole lot of graphing in of trig functions on your calculator. So I'm going to pull up a screenshot of what your window should be set to. In this case, it's telling you to make sure you're on the interval from 0 to 2 pi. So notice my x min to my x max, 0 to 2 pi. 6.28, of course, is 2 pi as a decimal. I scaled my x scale by pi over 4. You can do whatever you want. I just am trying to match this graph over here. It's scaling by pi over 4, so I changed that as well. And then knowing I'm only going up to or down to negative 0.6, I changed my y min and max to just -2 to +2, and I scaled by a half. Again, that's up to you, but just to get you thinking about that window. So in y1, type in sine of x. In y2, type in -0.6, and then we're going to calculate the intersection. Okay, so obviously you should definitely pick up your calculator and make sure you can do this, because listening to me explain it will probably make sense, but you need to make sure you can see this as well. Okay, so in my y1, I have sine of x. You can see that in blue. In my y2, I have the -0.6, that's this horizontal line. And between 0 and 2 pi, which my window is set to, I want to know what the solutions are. Okay, so I calculated this intersection, and you can see that it was at 3.78. So you can also see here's pi, right? So it's a little beyond pi, which makes sense because 3.14 is pi. The other intersection point, again, you would do it here. And if you don't recall how to do intersection, I will remind you, you just go second, trace, and then number 5 is intersect, right? So you can do that. And then you just press enter, enter, enter on all the questions. When you do that, you should get these two as your intersecting points. So 3.79, and this one here, which I don't have highlighted, is 5.64. Check it, dump those in your calculator. Oh, I did not clarify too. You definitely want to make sure that you are in radian mode. So please, we talked about that in a different video, but check your mode, make sure you're in radian, because this is in radians, right? If you're in degrees, it's a whole different story, and you won't see what I'm seeing for sure. So please make sure you can, spend some time and make that graph as well. Okay, last question then is going backwards. I'm going to give you a picture of a graph and ask you to write the equations. So we're going to find a cosine and a sine equation for this graph. So it clearly has some shifts and reflections, and it looks a little stretched out and all that good stuff. So here is my best advice to you. If you think about a cosine and a sine wave, the period can't change no matter which one you're looking at. I mean, think about period as a horizontal length. Well, if the period length is 3 pi, it's going to be 3 pi for sine and for cosine, because if not, it would be stretched differently, which is impossible, right? Okay, the midline. You can see the midline. Maybe you can see the midline. I'll just draw it in there if you can't. So where does this symmetrically cut in half? It cuts in half at y = 1. That has to be the midline, no matter if it's cosine or sine. Okay, so some of these things I know are fixed for both of them. Okay, so for example, the vertical shift, I know is up 1 because that's my midline. And I know that's going to be for both cosine and sine. The period length, well, pick a cycle. I don't care. I'm going to start here at -2 pi up at the maximum. If I start here, it's got to hit the min and come back up to the max. So that period length was from -2 pi all the way to 2 pi. What is that length? It's 4 pi. Okay, so the period is 4 pi. Once you know the period, then you can find the frequency. Now think about your equation for period is period equals 2 pi divided by k. So if I know the period is 4 pi, I just work this backwards for k. Multiply the k over, divide the 4 pi over. You can handle that math, and you should get 1/2. Also, it makes sense that there's half of a cycle in the distance of 2 pi. And you can see that in this distance, there's half of a cycle. In this distance, half a cycle. Okay, the amplitude is the height from the midline to a max or a min. That height is 2, right? It goes from 1 to 3. It goes from 1 to -1. So the amplitude is 2. So all of this stuff I have highlighted right here is going to be fixed. Like you cannot change that for either the cosine or the sine. But the horizontal shift, like where does a cosine wave start? Well, if I wanted my cosine wave to start here so that I didn't have to have a horizontal shift, okay, so I'm going to highlight that blue point right there. Then it would start at the minimum, hit the maximum, and then it would end down at 4 pi over here. Okay, but remember, cosine waves typically start at a maximum. So if I'm going to start here, what do I have to note? It's reflected. So I'm going to say I don't have any horizontal shift, but I also have to note that it's reflected. Okay, so now if you think about your cosine equation, it's y equals your amplitude 2, but it's also reflected, so I put a negative in front of that. Your k frequency, which is a half, times x, there's no horizontal shift, and then plus 1 vertical shift. Okay, now my sine equation, I can start my sine wave here, I can start it here, I could start it here, I can start it anywhere I want as long as it's on the midline, right? Sine starts on the midline. So let's say I wanted to start my cosine wave here. That clearly just shifted to the right pi. So my horizontal shift is to the right pi. So this equation is going to be identical for my sine equation, but I don't have a reflection because it goes up first. And I have a different horizontal shift. But see, my frequency is the same, my amplitude's the same, my vertical shift is the same. My horizontal shift is to the right pi, so I have to say x minus pi. Now, if you wanted to start your sine wave over here, that would be totally fine. Then it's reflected because it's going down first. So this would be a -2, and this would be a plus pi. Totally fine. I could start my sine wave over here. It's not reflected because it's going up first. It's shifted to the right, or excuse me, left 3 pi. So this would be plus 3 pi. So there are infinite answers technically to this graph, right? Again, your amplitude, frequency, and vertical shift, however, are not infinite possibilities. Those are fixed. All right, enjoy. Have a wonderful day.